Hello, my name is Jonavi.
And my name is Arya, and today we will be covering Lesson 1 of Programming.
But first, I'm going to introduce what we do as a team. We are a robotics team that builds, programs, and competes with robots through a program called FIRST.
So, what is FIRST? FIRST is a program founded to promote interest in the STEM field to students. There are over 600,000 members all around the world, and there are FIRST teams in 110 plus countries. FIRST has 4 different competitions for different ages. FIRST hosts several competitions, including the FIRST Global Challenge, which is an Olympic-style robotics tournament. Afghanistan's FIRST global team is comprised of all girls and won the international championship in 2017.
Now that we have introduced what we do, we're going to introduce the goal for you. We are calling this Mission to Mars. In Mission to Mars, you are mission control. It is like you are controlling a Mars rover almost 8,000 miles away. The Mars rover specs are 45 centimeters by 45 centimeters by 45 centimeters, and it is 9 kilograms. To program this rover, you are going to be using pseudocode. Pseudocode is a combination of English and programming, and it uses the structure of programming, but it is in an easy-to-read notation. The good thing about pseudocode is that you can apply the logic and the reasoning behind what you are programming to many programming languages. The way how you will be sending the code to the rover is for you to send pictures of your pseudocode, and then we're going to send video results.
We will be basing our lessons on Java, a programming language, or a way of giving specific instructions to a computer. A programming language is understood by both you and the computer. Java, specifically, is a programming language that is a commonly used programming language that is used to write Android apps. Java is an object-oriented, which means that it is based upon the creation and function of variables or objects. Objects are any data type or piece of information that we store. Data is any form of information that has been stored by the computer. Object-oriented programming is all about the transfer and storage of information.
Primitive data types. What are primitive data types? Primitive data types are storage categories for different types of data. Each variable you declare or create is either a primitive data type or another object. An example of a primitive data type is an int, which holds an integer value when you declare or create it. A few types of primitive data types are a double, which stores a number that can have decimals, a string, which can store any written text, which can be numbers, letters, symbols, etc., and a Boolean, which either stores true or false.
So how do we create or declare a variable? We first put the type, which is an int, double, string, or a Boolean. Then we give the variable a name, which should have some sort of meaning. You could camel case the variable name, which could include more than one word, but variable cannot have spaces. So to distinguish the words, you make the first letter capitalized. An example here is the variable called variable name, which has the two words variable and name. Finally, after naming the variable, we give the variable a value, which has to correspond with the variable type. For example, we can't declare an integer and set it to a value with a decimal, but we can set it to a number without a decimal, and let a double store the number with the decimal. In Java, we put a semicolon at the end of each line, but in pseudocode, which is what you are going to be using, you don't need to.
Some of the basic operators for numbers are plus, where you can add numbers, minus, where you can subtract numbers, asterisk or star, where you multiply numbers, slash, which is how you divide numbers, and a percent symbol, which is where you find the remainder after a number is divided by another. We can also increment and decrement numbers. increment means to increase the value of an integer or a double by 1, and decrement means to decrease the value of an int or a double by 1. To increment a number, after declaring it, we put plus plus next to the variable name. For example, we declare the integer x, and we set the value to equal to 1. In the next line, we put x plus plus, which now sets the value of x to be 2. To decrement the number, after declaring it, we put minus minus next to the variable name. For example, we declare the integer y, and we set the value to equal 1. In the next line, we put y minus minus, which now sets the value of y to be 0.
If we want to increase or decrease a number by more than 1, we use compound operators. To do this, after declaring a variable, we put plus equals, and then the value that we want to increase or decrease by the number. Here's an example to increase a number. We first declare that the variable x to be 5. Then we put x plus equals 2, and this increases x by 2. Now x is equal to 7. Here's an example to decrease a number. We first declare the variable to be 5. Then we put x minus equals 2, and this decreases x by 2. Now x is equal to 3. In Java, we can use the math class to perform complex mathematical operations. For example, the absolute value function would be difficult to perform. Thus, we can use the math function to perform absolute values, random number generation, square roots, and much more. For the absolute value function, we can use math.abs. Inside the parentheses that follow the abs, we place the number we want to take the absolute value of. For example, if x is equal to -3 and we perform math.abs on x, we will get 3. The same happens with the square root function. If we put a number in math.sqrt, it will return the square root of that number. For example, if x is equal to 4 and we place x into math.sqrt, it will return 2. Now please complete the practice problems on your worksheet. Once you have completed the worksheet, you can begin your programming challenge.
In today's programming challenge, you will be moving the robot to the goal position from its starting position. In the diagram, you can see the location of the robot, the location of the target, and the location of obstacles the robot needs to avoid. To move the robot, you will create two variables in your pseudocode, x and y. X and y will be doubles, meaning they are numbers with decimal values. Whatever you set x and y to, the robot will move it to. For example, if you set x and y both to 5, the robot will move to 5, 5 on the grid. However, that would hit an obstacle. To get the robot to the target, you may need to use multiple steps. Once you have completed your pseudocode, please send a picture of it to the Mars rover. In a couple of days, you will receive a video of your code working on the robot. Thank you so much for your attention today, and please feel free to email us with any questions.